Okay, so we're going to talk about physical and chemical properties and changes. Physical properties. These are characteristics that can be changed without changing the composition of the substance, or they can be observed without changing the substance. So these are directly observable, and these are things like odor, color, volume, what state it is in. Is it a solid, a liquid, or a gas? What is its density? What's its melting point? What's its boiling point? There's a whole bunch of other ones. But these are examples of physical properties. So you can measure the length of a piece of wood. That's a physical property. If you cut the wood in half and change the length of it, are the particles in the wood still wood? They are. You just made it smaller. If you take an ice cube and you melt it, you change its state, it's still water. It has just changed from the solid state into the liquid state. Because when we go from being in lecture to being in lab, from the solid state to the liquid state, do we as people change? Do we turn into elephants or something? No. We are unchanged. It's just how we're moving relative to each other that changes. So it's a physical change. Yes, question?
One of my friends told me a fun fact that glass is not solid, it's technically a liquid still.
Yeah, glass is technically, I believe, a very, very viscous liquid. And if they look at really old pieces of glass, hundreds of years old, they're thinner at the top than they are at the bottom because they're slowly running down. Really, really slowly. But yeah, it's kind of crazy to think about. Good question. Chemical properties. Chemical properties are a list of the substance's ability to form new substances. How does it react with other things? Some of these sentences, I look at them and I'm like, what? The characteristics that determine how the composition of matter changes as a result of contact with other matter or the influence of energy, right? That's just like right over the head, right? Blah, 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 blah. I feel like Charlie Brown's teacher sometimes. Chemical properties. These describe the behavior of matter. Okay, and when we demonstrate a chemical property, the chemical gets changed, the substance gets changed, the individual particles. So this is one of those things that we kind of have to just talk about the examples to understand. Flammability, okay, when something burns. Okay, this 3x5 carton. If I light this on fire, it'll burn, right? When it's done burning, is it still paper? No. It's not white anymore. It's not the same size. It doesn't have the same qualities anymore because the individual particles have been changed. This paper is mostly cellulose, and when we burn it, it mostly turns into carbon dioxide and water, which are gases, and they go floating away. That's a chemical property of this note card, that it will burn. When we demonstrate a chemical property, the particles that make it up are changed. We've destroyed the original substance. If I find the mass of this by putting it on a balance and seeing, it weighs, 0.3 grams or whatever, do I change the particles in it? No, it's still a piece of paper. That's a physical property. So when we demonstrate or we change a physical property, the substance remains the same, the individual particles. When we demonstrate a chemical property, we destroy the original substance. We destroy it. We change it into something else. Okay? So, concept check. Classify each of these as a physical property or a chemical property. So, ethyl alcohol boiling at 78 degrees Celsius. Well, let's think about this. What happens when you boil something? It's a state change, right? You go from the liquid state to the gas state. Does that change what the particles are? No. The particles are not changed. This is a physical change. Physical change. The hardness of a diamond. Diamonds are very hard. We can demonstrate the hardness of a diamond by, writing on glass with it or something. Does that change the composition of the diamond by demonstrating how hard it is? No. Even if we smash the diamond, if we hit it with a hammer and smashed it, would the individual particles still be the same? It would be in smaller pieces now, but it's still a diamond. The molecules, the particles are the same. So this is also a physical property.
Is it capable of melting a diamond? Can you melt it?
Can you melt a diamond? I'm not sure, actually. Some substances will melt, and some substances will combine and undergo a chemical reaction with other things before they melt. Like sugar. You can't get pure sugar just to melt by heating it on the stove. What happens to it? It caramelizes. It turns brown, and you get that characteristic smell of burning sugar. Okay? So some substances will react before they melt, and I'm not sure what diamonds would do. But like metals, you can melt metals. Some of them melt at lower temperatures than others. And you can melt salt, table salt, sodium chloride, you can melt that. It melts at really, really high temperatures though. But anytime you have something melting, it's a physical change. It's a state change. How about sugar fermenting to form ethyl alcohol? Chemical change. So you will be asked questions along these lines on an exam. So how do you go about figuring these things out? I try to ask questions that I think should be clear to a beginning chemistry student. Okay, I try. I think, well, they should know just from their general being alive, they should know this, and so maybe sometimes they don't. Things to look for in these sentences. Fermenting, maybe you know what it is, maybe you don't. Fermenting is going to be a chemical change, but this is critical here. To form. Anytime it does something, here you have one substance, whatever, to form something else, that's a chemical change. Because you started with one thing and you formed another thing. If you see the name of a state change, boiling, freezing, melting, condensing, anything like that, that's always going to be a physical change. Oh, yes. There's the answers. Good, we got them correct. And they show them again. Okay, physical changes. So we talked about chemical properties and physical properties. And then we have chemical and physical changes. So a physical change, we change the form of the substance, not its composition. So examples are state changes, boiling or freezing. That's a physical change. The physical property would be the temperature at which that happens. If we take a piece of wood and we cut it in half, that's a physical change. Okay, we've changed its size. It is different now. If we take sand and salt and mix them together, mixing two things together is a physical change, but we haven't changed their particles. So this is looking at state changes. If we look at the water, we have these illustrations of the water. We see that in all three phases, the molecules are intact. Okay, so when you change the state, the molecules don't change, just like the students don't change when we go from lecture to lab or from when we leave. What changes is the motion of the particles and the distances between them. Particles are always moving, molecules and atoms. But in a solid, they do not move relative to each other. In a liquid, they move relative to each other. They like people mingling at a party or in lab or milling about. Okay, still close together, but the motion has changed. And you go from a liquid to a gas, and the distance changes. Okay, so those are the important things that are changing. The particles themselves are not changing. So that's physical changes. Chemical changes. In a chemical change, the substance becomes a new substance. The old substance doesn't exist anymore. We have a new substance, and that new substance will have different properties and a different composition. Chemical changes are also called chemical reactions. Chemical reaction, chemical change, exactly the same thing. Two different names for the same thing. An example of that is in your Bunsen burner. Okay, we hook the Bunsen burner up to the gas jets and we light it and we get a flame. What's happening? Well, the natural gas, the methane, is reacting with oxygen in the air and it's forming carbon dioxide and water. Forming. It's a chemical change. We started out with methane, which is CH4, and we've got O2, oxygen in the air. And after it combines this way, we have CO2 and H2O. It's different. Okay? Methane is flammable. Oxygen is flammable. Carbon dioxide is not flammable. Water is not flammable. And so we've gone from things that are flammable to things that are not flammable. Their properties have changed. Okay? Here is an example. I can never remember. No. Never remember if there's any words that go with that slide or not. There aren't. Electrolysis of water. So here's this fancy setup, and you've got water in here, and it's up to here on one side and up to there on the other side. And you've got this big battery here, and you're passing current through the water. This causes water to undergo a chemical change. It breaks the water apart. And we get oxygen gas forming at one electrode, and we get hydrogen gas forming at the other electrode. This is a chemical change. The properties of the water have changed. Water is a liquid at room temperature. Hydrogen and oxygen are gases at room temperature. Water is not flammable. In fact, we use it to put out fires. Oxygen and hydrogen are both very flammable. It's a chemical change. The individual particles have changed, and their properties have changed. So the water decomposes, breaks apart. This is an illustration of what the water molecule looks like. It looks like a little teddy bear or a Mickey Mouse head. So if we have two of those water molecules, they are going to come apart and be reformed into two hydrogen molecules and one oxygen molecule. Have you guys played with Lego bricks at some point in your life? Okay, my children have probably 1 million Legos, and I'm not overestimating. We have a lot of Legos. We've been collecting Legos for about 18 years. So we've got a lot of Lego bricks because you never throw them away. They're expensive, and they keep playing with them. The 20-year-old still asked for Legos for Christmas. Not a big set, but he just wanted a little one in his stocking.
The more you have, the bigger you build.
Yeah, you know, and they just have fun with them. So, but Legos, let's think about Legos. So this is a little bit like you made this little Lego thing, really boring thing, maybe something like Andrew, the 4-year-old, would make, where you have maybe a red 2x4 brick and two blue 2x2 bricks, and you made this little thing. And here's another one. Well, in this chemical reaction, what happens is you take apart the things that were built here and you put them together in a different way. There were no Lego blocks that were created in that process. There were no Lego blocks that were destroyed in that process. Now, can you destroy a Lego block? Well, if you took a sledgehammer and smashed it, or a hacksaw, you could probably cut it in half, right? That's like a nuclear process, though. That's like overkill, right? So playing with your bare hands, most of those pieces you can't break. Thinking just the regular bricks, not those really long, skinny ones. Those, yeah, they break when you, yeah. But the regular ones, like a 2x4 Lego brick, you cannot break that with your bare hands, can you? These atoms in a regular chemical change do not get destroyed. So whatever you start with, you have to end up with. But in a chemical change, the way they're put together changes, and that causes a change in their properties. So concept check. How many of the following are examples of a chemical change? So let's just pick them off one by one. Pulverizing, which means crushing rock salt. Not a chemical change. How about burning wood? Yes. So that one is chemical change. How about dissolving sugar in water? No, not chemical. It's physical. And that's one that's not real obvious to a lot of beginning students. So let's think about it. What happens if you dissolve sugar in water and then you let that sit there until all the water evaporates? What do you have left in the glass? The sugar is still there, right? Because all that happened was that we mixed the sugar and the water. You may say, but the sugar disappeared. Well, yeah, it appeared to disappear. It dissolved in the water. It mixed up really, really well, but it's still there. If you taste the water, you can still taste the sugar. When something dissolves, it's a physical change. It's just mixing.
So, how about when you do salt in water?
When you dissolve salt in water, what is that? Well, that's also a physical change. Okay? So this dissolving sugar in water, not chemical. How about melting a popsicle on a warm summer day? Nope. Physical change, because if you collected that and froze it again, you'd still have the same substance. Melting is a state change. All state changes are physical changes. So one of those, that's a really bad one. One of those is a chemical change. That one. Another concept check. Classify each as a physical or chemical change. Okay, sugar fermenting to form ethyl alcohol. That's chemical. How about iron metal melting? Physical. That's a state change, right? The first one says to form. That's your clue. That's chemical. The second one has the name of a state change. That's going to be physical. Iron combining with oxygen to form rust. Chemical. So we're kind of looking for key words in a lot of these things. To form. You start out with iron and oxygen, and you form rust. It's not the same anymore. Chemical, physical, chemical. Good, we got those right. It's always a bummer when the teacher gets them wrong.